Hello and welcome back. In this video, Lee is going to get us going with Well 512. So basically this is going to be an introduction to and setup for Well 512. Lee?
Right. It will be our first true pseudo-random number generator. Up to this point, we've been playing around with some hashes. Some really good hashes, as it turns out, better than the better hashes that I was going to do. But hashes no less. They're not random number generators as they are. But we are going to make our very first one, that one being the Well 512. But before I get into, can I get a little help here? There we go.
Oh,
Thanks.
you did it.
I was just waiting. Is like, before we get into it, I'd like to recommend anybody who wants to read more about this, definitely do some searches. Wiki has some good stuff. One of the better papers that I found was this one, which does a very good overview of the different types of number generators that are out there, gives you some background and breaks it down into the cryptographic level algorithms, the non-cryptographic, and as well as hardware random number generators. And for the most part, it appears that this is ordered from the lower quality generators up through the higher quality, which is kind of neat. And it's got all the math that you could ever possibly want.
Oh, I doubt it's all the math you could possibly ever want.
Well, all the math I could ever possibly want.
For people like
And
me,
more.
it's, yeah, way beyond. Yeah, exactly.
Right. Now, one of the things that I wanted to stop at is this one. I'm probably going to butcher the name, the Mersenne Twister. This is probably one of the more popular generators that are out there that people talk about when you start doing a lot of searches and initial research. And I started looking at implementing this one, but the code is fairly complicated. The other thing is, apparently, if you can get the first 623 or the first 624 numbers in a sequence, you have all the information that you need to determine the remaining states. So it's easily crackable. So this is definitely not a cryptographic level, number generator. Another problem is that it suffers from that zero state issue. If you remember when we first played with the built-in one, and we only ran the first 100 iterations, where most of the numbers were biased between 0 and 0.5 as opposed to above. But as we got more and more numbers, it started balancing out. The Mersenne Twister is another one that suffers from that type of problem, where if the initial seeding information is heavily loaded with zeros as opposed to an equal distribution of ones and zeros, it will be biased towards zero. It's one of the things that the guy who created this, the Matsumoto,
Hmm.
went back with some other colleagues, and he came up with the Well algorithm. Now, the Well algorithm is a little bit further down here. It's the last one we get into before we jump into the cryptographic level ones. This guy is quite interesting. It's basically Matsumoto and some other people came up with this new version. It is designed in several flavors. You've got the 512, 521, all the way up to this 44,491.
97.
97. Just the 512 version has 10 to the 154 power. Basically more than any video game could possibly need as far as numbers in a sequence before it repeats. Now, this is an interesting little comment that they make. Basically, it's larger than the number of particles in the universe. And Jason and I were wondering, who went out and counted all the particles in the universe?
Just say you have to say in the known universe.
Yeah, it's like going, that job would suck. Could you imagine that?
Yeah, no, I don't even want to think about that.
So, but as I showed before when we brought up the calculator way back in the intro, the size of the number and even if we took my computer and broke it down in how many millennia, it was an insane number. They also make the claim that a standard PC takes over a Google of years to count that high. Now, that's just the 512. Could you imagine what this one's like?
Oof.
So that would probably give you a lot of numbers. Now, one of the things that they say is with that one, that's used mostly for simulation type stuff. The higher order ones are for doing weather simulation or Earth simulation.
And instead of calling it the higher ones, you can just start calling it the larger periods or the higher periods.
Right, the larger periods, because all of these are
they all define periods basically.
Right, of how many powers of 2 before you get a repeating. So, which all goes based off of the Well name. Well Equidistributed Long-Period Linear. So that's the name of it. Now, my guess is these longer ones also have the real nice added bonus that you get a lot more numbers that you can generate before you start getting repeated numbers. If you remember some of our earlier experiments, one of the things that we're trying to do is when we're just generating 1,000,000 numbers, we're getting about 3,600 duplicated numbers. These longer period versions probably can go substantially longer before you get a repeat. Unfortunately, I don't have the computer nor the time to hand over for it to generate enough numbers to find out how far out that could go.
Right.
So now the cool thing is they were kind enough to include some of the code that is needed inside of these different algorithms for implementing on your own. So if you want to experiment with any of the other ones, highly encourage looking at this paper as well as researching Wiki and some of the other sites. But from everything I've read and everything I've tested, it looks like this Well 512 is going to be pretty much everything that we're going to need as far as a pseudo-random number generator for testing purposes. That could change, who knows, but this is R&D, but this is the one that we're going to go with. So in the next video, we're going to actually jump in and start laying in the groundwork and get ready to implement this. So
Okay, well then we'll move over to the next video. Thanks a lot, everyone.